Hi everyone, I'm Wigo, Assistant Professor of Medical Engineering at Caltech. Today it's wonderful to be here to share our research on skin interface wearable biosensors. Wearables can play a very important role in personalized healthcare because they can continuously collect data from our body and tell us what's going on and what's going wrong with our health. But if you look at the commercially available health monitors like Apple Watch or Fitbit, they can mainly track the physical activities of vital signs, but failed to provide more useful information about our health and molecular level. A major challenge, which is also a great opportunity in the wearable sensor field, is how can we collect missing chemical of molecular information continuously and ideally non-invasively. So we are mainly looking at analyzing human sweat. Sweat is an important body fluid which can be retrieved conveniently, continuously, and non-invasively. Sweat contains many important biomarkers which has close relation with our health conditions. And these biomarkers include electrolytes, metabolites, amino acid, vitamins, hormones, proteins, and many substances. We have developed a fully integrated wearable sweat sensor platform that can perform real-time multiplex sensing of sweat metabolites, electrolytes, nutrients, drugs, along with other vital signs. So this system can perform on-site signal conditioning, processing, and wireless transmission. We also have an integrated on-demand sweat extraction module, allow us to get sweat locally beyond physical exercise. So all the data can be collected through the cell phone and displayed on a custom developed cell phone app, or we can easily save this to the cloud or save this in the phone. So very recently, to make the wearable sensor patch a large scale and low cost, we proposed a laser engraving method. Simply using carbon dioxide laser engraving, we can make the beautiful graphene structure on the surface of a polyimide. So based on this, we can design high performance chemical sensor, high performance physical sensor, along with the microfluidics. Because microfluidics can also be laser engraved and can sample sweat efficiently, allow us to miniaturize the influence from skin contamination or sweat evaporation. So in this case, we have this high performance multimodal wearable sensor. And importantly, this sensor can be manufactured at larger scale, low cost. So based on this, we can apply our sensor for various applications. Here, I want to show you two examples. The first one is we can apply our wearable sweat sensor for metabolic and nutritional monitoring. So we can use our wearable sweat sensor to analyze some nutrients or metabolites. Here, one example is uric acid. Uric acid is a biomarker for gout arthritis affecting tens of millions of population around the world. So by monitoring uric acid, we can monitor or manage gout in general to miniaturize the chance for developing gout or gout attack. So we recruited the patients with gout. If you look at uric acid level in both sweat and serum, they show very similar pattern. And we can track the sweat over time, and sweat uric acid follows closely to serum ones. And we observed a very high correlation between sweat and serum uric acid level. This is just one example. We can apply our sensor to monitor a number of different kinds of metabolites and nutrients toward cardiometabolic disorder monitoring. Another application is we can use our wearable sensor or telemedicine sensor for monitor stress or mental health. Right now, stress mostly measured by questionnaires, which could be very subjective. We could also access stress biomarkers such as stress hormone cortisol. But if we draw blood to analyze the cortisol, blood drawn by itself is a stress-inducing event, making your measurement not very accurate, right? So we propose this telemedicine platform that can non-invasively monitor stress hormone levels through analyzing sweat. So this sensor can rapidly measure cortisol level within 1.5 minutes, in fact. So we observe the high correlation between sweat and blood cortisol level. We also observe the circadian rhythm of stress hormone level in human sweat. We can see in sweat, the morning cortisol level is higher than afternoon. And when we have different kind of stressor applied on the subject, we see dynamic changes of stress hormone level. We can apply this for dynamically monitor stress response or mental health. So In summary, we proposed this platform, telemedicine biosensors that can quantify the biomarkers in our body fluid non-invasively for at-home health monitoring. What we are looking for? So we are looking for research collaborations toward new applications. We are also looking for commercial partnerships for potentially commercializing our technologies. And of course, we are also looking for funding and grant opportunities. Thank you very much for your attention.